Yeah, hello everyone. Welcome to Racks Infotech. This is Mohammed Mujib. Okay, I I have more than 12 years experience in Oracle E-Business Suite as an GBA, and I also took care uh, of the Oracle databases, multiple versions. So I have more experience in Oracle E-Business Suite as an apps DBA. So we also look after the databases as well, core database as a part of the whole instances. So today we are going to discuss about Oracle DataGuard, which is very important session, very important topic in Oracle 19C database. Yeah, let me, okay. Yeah, so Oracle DataGuard is a very important topic in Oracle database, and from version to version, it has been evolved. Now, many features have been introduced. So in 19C, we are up to date in terms of functionality and all the processes and features have been introduced. Okay, so the data guard, what is data guard actually? So we have production databases, very critical databases running. Okay, so where client can't afford outages, very long outages due to some issues. If something happens to the production one databases, then the whole application goes down and can't connect to the databases, and the end users will suffer. And so much huge loss to the customer happens if the outage is in a couple of hours or for one day or couple of if the outage is for more than 2, 3, 4 hours also, then the client has to face so much reputation damage, and they have to face this huge data this loss as well. Uh, and when the databases are, the client is very crucial systems are running, when they are running, like the financial databases applications they are using, or very critical when uh, the databases have to be run 24/7 and can't go down during business hours. Okay, where the databases will run for 24/7. Okay, so there we can't afford, client can't afford the outage. So in that case, we have to go for the data guard. So why the data guard we have to use when we have the rack instance? I mean, rack functionality is already there um, in Oracle databases. So rack is actually is also for high availability, and when one of the instances where we have, like for um, Oracle rack, we have more than 2 instances as well, like 3, 4 as well. Okay, so when one of the instance goes down, the end users will connect to the second instance or third instance, whatever. But here, if the site goes down, then what happens? So in that case, um, due to some outages, like system failure can also happen, like the natural disasters or other disasters can also happen anytime. So we have to prepare, the system has to continue, the business continue plan will be in place. Otherwise, they have to face, the client has to face so much loss in terms of financial also, the reputation also goes down. So for couple of hours outage also impact a lot. So in that case, rack also doesn't, it is not a it's not a savior. So here the data guard is a savior actually. So what is data guard actually? So data guard is actually where the production is running on one of the site. So the similar kind of another databases, 1 or 2, 3 databases, standby databases will be created in other sites where it's not closer to the completely geographically different sites where the databases are running, exactly duplicate to the production one. And from production to those standby databases, the log ship happens, or the changes will happen from production to the primary to the standby one. Okay, so in case the production goes down or something happens to the production, so within, I mean, not they don't have to wait so much time. Immediately, we can activate the standby database, and the users can connect. The application can continue to use by connecting to the standby database, and end users can't. They don't know whether they have connected to the production primary one, the standby database. So the main purpose of the data grid is actually this is for high availability and for data production as well and disaster recovery. The purpose is actually disaster recovery. Something happens to the production side, the other production similar kind of uh, database has to be there so that immediately we can switch. Uh, the failover can happen to the second standby database and users can connect to the database. Okay, the same has been discussed here. Okay, um, we can maintain a physical standby database, single standby database, or multiple more than one also we can maintain. Okay, unstable. Yeah. So what are the benefits of Oracle 19C data guard? The same discussed like in the earlier slide, previous slide. For high availability, for and data guard is also helps to protect the data and for disaster recovery also. Okay. Um, so here we can discuss about the two important topics in coming slides, like the failover and the switchover. So what is failover and switchover? We can discuss in coming slides. So failover is actually when something happens to the production side, failover happens to the second one, the standby one, that is called as a failover. And switchover means when for the maintenance activity, it's like we do the drills, right? Uh, Same kind of fire drills we do the right when something disaster happens in corporate offices. So the same kind of DR drill we have to do here. In case the production goes down, it's supposed to be in a very good condition that it automatically or manual method also it should convert the physical standby database to the production. Okay, and we can use standby database for rolling upgrades and patching as well, patching activities to carry out the patching activities. And the main purpose is to avoid or minimize the downtime. So if we don't have any standby database, the impact is very huge, and the outage also is huge. Okay, so how? Let me share my experience. I actually supported one of the clients where uh, data guard was not in place due to file system corruption. We had to restore, and recover whole database, which took more than 15 to 20 years. Okay, we had to restore, rebuild the file systems first and then restore complete. Fortunately, at that time, we had full backup and incremental backups as well. So the OS team had to completely create a new file system. Then we had to restore and recover. Okay, and without data loss, we were able to restore and recover the database. So which took so much time because at the time the client didn't have this one, the data guard in place. So it took so much time to restore and recover it due to system failure happened. Okay, so in that case, in that scenario, if we had a data guard, within a couple of minutes or within half an hour, uh, we were able to switch to the standby database and made that database available to the end users using application. So data guard plays a very important role when the client has a very crucial databases, okay, where the application should not go down for long time. Okay, coming to the architecture of the data guard. Okay, here we have primary database where the production is running. Here, this is the standby database, physical standby database. So what we do actually in primary database, we have to, from primary database, we have to create a standby database, physical standby database. Excuse me. For that, every time this production database has to be running in arclog mode. And during follow, we have to follow few method, few steps to create a physical standby database. Okay. So what is the architecture of this DATAGUARD? So here, as you know, in earlier sessions, Srinivas has already discussed about what are the processes involved uh, in Oracle databases. So same thing here as well. Okay. So we have production primary database here. So whatever the changes are happen to this production database, primary database, those are writing to the coming to the redo log buffer. So the log writer has to read those redo log changes and write it to the redo logs. Okay. So here the archiver processor, when the redo log switch happens, okay, so this archive process reads those changes and creates archive log files. Okay, the same. Uh, so during over the Oracle net service, so how these redo logs are getting transferred and applied to the physical database here. So in this is we have two important processes like LNS and RFS. LNS is stand for long network service and RFS is stand for remote file or fetch service. Okay, so when a log writer is reading those changes from the redo log buffer, okay, in synchronized method we have like two methods here: synchronization method and sync method. So here, when a log writer is reading redo log changes, okay, and writing it to the redo logs. So here, the what LNS is does in synchronization process, it directly reads from here, from redo log buffer, and transfer those changes reduce to the other side, standby side. Here is the RFS, the process which receive these changes, okay, and writes those changes to the standby redo logs. Here, these redo logs are different. Here we call it as online redo log. Okay, here these redo logs are standby redo logs. So RFS process directly writes took those changes as a redo logs and apply here. Okay, so here the next step is actually to create whether the to create the archive processes using archive log methods or not. That is up to us. Okay, here here in physical standards we have process like MRP, okay, managed recovery process, which take care of these redo changes and apply it to the physical standby database. Okay, and we have LSP as well. We have two or three standby databases. Like physical, we have physical standby database, logical standby database, and snapshot standby database. So we have two processes like MRP and LSP. For MRP in physical standby database, these changes are getting applied through this MRP process to the physical one. And logical, we have another logical standby database as well. Okay, so LSP is a process which writes those. This process actually doesn't directly apply the redo logs to the standby database, physical standby database in logical. So in logical, what happens? The redo logs actually transferred from here, from primary to the logical standby database. From here, actually, it regenerates the SQL code and applies here. So LSP is taking care of those regenerating the statements, SQL statement, DMS statements, and applies directly to redo logs. Okay. Okay. So what is this? This archive process directly reading from the redo logs, this RFS process. So when the switch happens, okay, when LNS is actually behind, a little bit behind when log writer is writing Okay, from redo log buffer to the online redo log, and log switches happens very frequently. And LNS process is very if the process is slow than this one, the log writer. So instead of reading from redo log buffer, this LNS can directly read from the redo logs, okay, and apply it to the RFS process, okay. And this archive process, when there is a suppose redo logs are when there is a gap in redo logs between primary and physical standby databases, okay. Instead of this archive process directly can read from the redo logs and transfer it to the RFS and apply it to the physical standby database. Okay, so this is the architecture. So this LNS and RFS also very important here to ship the redo logs and apply it here to the physical standby database. Okay, so coming to protection modes, we have multiple protection modes in DATAGUARD. Okay, so protection mode, we also call it as redo transport rules, how the redo logs are getting transferred from primary to standby. Okay, so in any one of the production mode has to be enabled in DATAGUARD. Okay, the default one is maximum performance, which is recommended. Okay. So what happens in maximum availability and maximum performance and maximum production? Okay, let me explain in detail. So in maximum availability, what happens? So here for maximum availability, which is sync method, okay? So redo logs are applied to the standby database first with before committing it to the production primary side. So once the redo logs are transferred to the standby database where it applies and uh, it gives the confirmation acknowledgement to the primary one where this redo logs are already applied to the physical one. Okay, so then only these redos are commits there in the primary one. Okay, it is in the availability mode. So maximum performance is the default one. Okay, where it doesn't wait for redos to apply in physical standby. So what it does, it directly first commits here. It directly commits here. Okay, in the primary side, and then later it transferred the redos to the standby database. Okay, which is a default one, also recommended one. And we have third one, maximum production mode, which is not recommended because in maximum production mode, what happens if the redos are actually not getting applied to the physical standby, or if the physical standby is not available to write the redo, then what it does actually, it brings down the primary database. So we can't recommend that one. I mean, Oracle also not doesn't recommend this maximum protection mode. And if the client wants to go for the maximum protection one, okay, in maximum protection one, what happens? It completely 100% the data will be accurate in both or in source and the target, like in primary and physical. Okay, so the default one is maximum performance mode, which is recommended one. So same thing, we can have multiple single or multiple physical standby databases, okay, on different sites. Suppose if we have a production one in Bangalore, and the other one we can keep it in physical standby, keep it in Hyderabad, and one third one is can be kept in Delhi or somewhere. So geographically different. Like, natural calamities can happen anytime. We can't guess that. So if something happens to any one of the production one, the other physical database can be activated and uh, bring that, convert that physical to the production one and make that available to the end users. Here, okay, standby types, we have physical standby, okay, logical standby, okay, and snapshot standby. And one more, we have active data guard as well. So what happens in physical standby database? Like the discussion happened right in the earlier slide, physical for physical standby database and for snapshot standby database. So in physical standby database, the redos are getting transferred from primary to the physical standby database, where the redo gets applied to uh, physical standby, where the database is actually in mount state, where it is receiving and getting applied those redo changes. So coming to the active guard, okay, active data guard. So we can in active data guard, we can bring the database up, like we can open the database in open and open in read mode, okay, but we can't write it. So for reporting purpose, we can use this one, but it doesn't come free. It costs to the customer, like it's a licensed one. Okay, when client doesn't go and doesn't want to go for the active data guard, okay, they can go for logical standby. Okay, what happens to the logical standby? So in logical standby, the redos are actually not getting transferred and applied directly. Instead of that, the redos are getting transferred from primary to standby. Okay, where uh, where this LSP process is converting, regenerating the SQL statements from the redo logs and apply to the physical logical standby database. Okay, where the SQL actually regenerates and applied to the logical database, where the database can be open with the read write mode. And the last one is snapshot database. Snapshot in snapshot standby database, uh, where it doesn't apply the redo logs. Okay, it doesn't apply. It does. So snapshot database can be, suppose if we have physical database where it can be available with the mount, we can convert this physical standby database from physical to snapshot. Okay, but here in snapshot mode, we can open the database with the read write. Okay, once it has converted from physical to snapshot standby database, the reduce doesn't apply. Okay, because it actually guaranteed a restored point it creates when we switch from physical to snapshot. Okay, and suppose uh, why actually the snapshot standby database we are converting from physical to snapshot standby database. If the client wants to use that standby database, physical standby database for some testing purpose to create some objects or tables, okay, then we can convert this switch from physical to snapshot, and they can create tables or whatever the data, okay, but those changes can't be applied. So once you switch the snapshot standby database from snapshot to the physical one, so from RFA, from flash recovery area, it takes those logs and creates, revert it back to the original one, the physical one. So here, the, so it doesn't apply the redo logs actually, and can be opened in read write mode. So what services are used to keep the standby database sync with primary? Okay, we have like redo stream. Okay, redo transport service is used for transmission of redo information from primary database to one or more standby database. Okay, so we can call this as a physical standby. And for where the redo or SQL are getting applied, there's a logical one. It means how it maintains how the database applied to standby database by one of the following. Like instead of redo, the SQLs are getting generated from the redos and applied to the physiological standby database. So coming to switchover and failover. we have two slides here, switchover and failover. So what is switchover? Okay, like we discussed earlier, uh, like the DR drill we have to do to make sure that in case of anything happens to the production one, okay, so the physical standby database supposed to be in a very good condition in that case, okay, to act as a primary one. To make sure that we have to do the switchover activities. So when the data guard is actually enabled, we have to discuss with, we have to take the approval from the client that, okay, so how soon, how frequently we have to do the switchovers, like monthly ones or at least in quarterly ones, 3 months, once in 3 months. Okay, the switchover, like what is switchover? So suppose this is a primary database, okay, and this is standby database. So switchover activity is actually, we have to bring this, suppose we have to, in switchover activity, primary database can be converted from primary to standby, and standby can be converted from standby to the primary. Okay, so same thing. So role reversal happens here. So Oracle data guard helps you to change the role of the database between primary and standby using either a switchover or failover operation. Okay, role reversal happens. Okay, so this has to be done actually by the DBAs. So this is planned maintenance activity, or over on the weekends we have to do monthly ones, or if the client is not allowing us to do that switchover activities, at least once in 3 months we have to do it, so that in critical times, in failover, when system failure happens or some disaster happens, at the time uh, it should be in a position to failover to the failover happens. Okay, and failover, what is failover? So failover is the same thing, but a different one. There in switchover, it's planned activity. We are actually we are doing the DR drill actually. So we are creating that scenario to make that primary database as a standby and standby as a primary like that. But here it's failover means it automatically does it, or manual method also we have to do it if automatically is not working. So where production database is going down, where if the production goes down, okay, so failover means automatically the physical standby has to be converted automatically to primary one. Okay, within couple of minutes we can make that happen. Okay, and end users can connect to this new primary, and application also connect. Okay, uh, so without data guard, it is very difficult and it time consuming task to restore and to build a new server and make that database and application to the end users. If data guard is already in place, when failover happens, within a couple of minutes, end users who can't actually know also that actually they are connected to the new system. Okay, so this is unplanned, actually unplanned activity. Some hardware failure happens or disaster happens, then only the failure happens. So monitoring and maintaining data guard. So we have data guard broker, and we have monitoring tools and utilities. Okay, best practices for maintenance. Okay, so what is actually data broker? Data guard broker. So data guard broker is a distributed management framework, okay, which automates the creation, maintenance, and monitoring of Oracle data guard configuration. So when you enable data guard broker, okay, there is a command line actually, DGM, uh, DGM GRL, okay. So this is command line interface. Using that, we can actually uh, do the data guard configurations. So data guard broker actually simplifies the switchovers and failovers, okay, by allowing you to invoke them using a single click, using OEM control, cloud control, or using a single command in DGM GRL. okay, using command line interface. So this is DATAGUARD broker. It simplifies the DATAGUARD configuration activities. So monitoring tools and utilities using DGM GRL, okay, using command line interface, and when it integrates with the OEM cloud control uh, for monitoring purpose, okay. And for best practices for maintenance means this is for switchover activities. So steps to configure DATAGUARD. So as in first slide, what we discussed the how we create the standby database from the primary one. Okay, when we have primary database with arclog mode, so we have steps, force logging and everything, make that primary okay ready for the to create a physical standby database. Okay. From